Okay, so let me just say that real quick again. So we're updating our formula sheet. If you're watching the video, just pause it right here because I'm going to be taking it down before you could probably find your pink sheet and write it. So just pause the video. Also, good news is our school board approved us not having exams first semester. So I'm sorry? No.
No? Oh, so
not that I know of, no.
I thought AP was still say AP teachers that make them.
No. No exams first semester at all. They're still second semester. So listen, what that means for our class in particular, just I can only speak for myself, is that builds in like 7 extra days, about 7 or 8. Because in our schedule, I always have review days, and then of course there's like all those days of exams. So now they are class periods that I can do whatever I want with. So what I was able to do with our schedule is slow down a little bit and build in some work days. And so we're going to have more work days this quarter than we did last quarter. Our next one is going to be this coming up Monday. Work days I love them for you. They're kind of boring for me. I'd rather teach, but I like them for you because it's a day, as I always say, to catch your breath. It's a day for you to finish any homework assignments that you didn't finish. You can get my attention. I can help you. Like, she went over that example 4 way too fast. I don't know what she was saying. I'm going to ask her on the work day or when I get a chance. But you can watch videos. You can work on homeworks. You can ask for help. You can work together on anything you want. It's a day to work on my class, though. Let's remember that. Those are also good days to do homework checks because then I'm not taking like teaching time to check homework. So I always try to do homework checks on those days. So our next homework check is Monday, along with a work day. And also we have a quiz opening on Thursday, which is tomorrow, through next Wednesday. My online quizzes are usually about a week long. That gives you plenty of time to figure out when it works for you to do it. That's why I don't do makeups, because it's not like I give you one day to do it. It's a whole week, okay? And I try really hard to make sure there is an in-class day in that time period for you to work. That doesn't mean I will always be able to do that, as you might have seen. I don't remember what happened last quarter, but it could happen that there's a quiz that's open without a work day in there, all right? So just think about when you can make this work. My quizzes are always open the morning of that day and at midnight that other day, and there's no makeups for them, okay? So, be careful, my friends, that you don't say, okay, perfect, I'm going to work on my quiz on Monday. Then you're absent Monday, or your laptop died, or whatever, some other emergency happens. So you still have a couple more days, but just let's be on top of when things are due. Like yesterday was the progress monitoring check. I haven't looked yet, but I have a feeling there are people that didn't do it. And I had it open for a whole week and had a class day for you guys to work on that. So here, we really don't have excuses in this class anymore as far as like, I didn't know where to find this or how to do that, because I do everything the same. So guys, get organized. And it starts like we're a fresh new quarter right now. We probably won't get the homework done in class today. Have a way that works for you. I wouldn't tell you at all how to do that. Have a way that works for you that okay, I need to finish this homework problem, or star this, highlight this. I need her to explain this better to me on a work day or whatever. And that way, when it comes time for a work day, you're really productive. Okay, I know I need to ask her about this. I need to finish this. I need to watch this video or work on this quiz. Let's be productive and use those work days for what they're meant for, is to work. Okay? Any questions for me before we start? 2.2 is one of my favorite sections in Unit 2. I love the connection we're about to make between what we just learned, which is arithmetic and geometric sequences, and stuff that we did in past math, including today, this year's math, and that's this. I'm kind of going all over the place. I'm going to explain it by reading here. There's a relationship between linear functions, a line, and arithmetic sequences, which is what we've been working on. So today we're just talking about arithmetic. Tomorrow we'll make a connection between something and geometric sequences. We know that a linear function in this form, y equals mx plus b, describes a continuous function whose domain and range is all real numbers. Pause, let's explain that. Domain and range of lines, all real numbers, right? Every X, every Y gets used. That's why they're so easy. There was no asymptotes. There's no holes. They're just simple, right? They're just pretty basic. And continuous means that if you graphed some points of a line, you could then just make a continuous smooth line that goes through those 2 points and continues on forever. It's continuous, right? Negative infinity to infinity in all directions. And the y-intercept is 0b. Y equals mx plus b. B is your y-intercept. Y-intercept always has an x value of 0. And the rate of change of the function is the value of m, which represents the slope of the line, right? Okay, back to this AROC. That's your slope, right? That rate of change. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We're going to be using that formula again. We're using slope-intercept formula again. We're using this explicit formula today, so it's great that we pulled that out today. Our arithmetic sequences can be represented by linear functions. This is everything right here. Arithmetic functions and arithmetic sequences and linear functions are really the same thing with one slight difference, and that is the domain of sequences is not all real numbers, okay? So that may not make sense yet, but I'm going to explain it in these first examples. So how are they connected? Really cool. Use the graph of the sequence. So they're telling us they graphed a sequence, the first term, the second term, the third term, and they're calling the term number the x values, and then whatever the y value is that term, okay? So all we're going to do is look at this graph and pull the points right off. Like they gave us 1, -5. So that's saying the first term is -5. The second term is -3. And I'm just going to go ahead and, so we don't have to spend a lot of time on this, understand the way I got those numbers is I just pulled them right off the graph. Also, they want us to find 0, which is the x-intercept. Well, if this is a arithmetic sequence, what do we know about that? Well, we know that we're adding the same number as we go left to right. What would that number be in this case? Yeah, we're adding 2, right? We're adding 2 as we go left to right. So if I want to go in this direction, I would do what? Subtract 2. So my y-intercept would be -7, which makes sense visually, right? There's my y-intercept of 0, -7. So guess what that 2 is? That d, which is 2, is also our slope of 2. Big connection. Slope and common difference are the same thing. We're going up 2, right 1, up 2, right 1, up 2, right 1. We're adding 2, adding 2, adding 2 as we go through the sequence. Okay, they are the same thing. So what we're going to do is find the d. Okay, we already did, thank you very much. D is 2. And we're going to write an explicit rule. Understand the language. Explicit formula, explicit rule, general rule, call it all different things. Remember, to do that, we start with a sub n. Anytime we write the explicit formula, we leave n empty, blank. And remember, you can choose any number you want in the sequence. It does not matter what you make your a sub k. So I'm going to write the formula again. You don't have to if you don't want to, but again, the more you write this, the better it gets in your brain. Now remember, I can choose any number I want. If I'm going to be my own boring self and pick the first term, that would be -5. Then my d value, always leave n empty, and depending on what I pick here, this number will change. I chose the first term, so my k value is 1, okay? If you chose the number 3 to put here, look guys, if I put a 3 right here where my -5 is, what would I have in place of the 1? It would be 5. Every single one of us could have a different answer right here. Depending on what you chose here, that will change this number. Remember that, okay? So if I put a -1 here, this would be a 3. If I put a 1 here, this would be a 4. Remember, k is whatever term number you are, okay? But we always simplify this. We're going to go ahead and simplify this, and that's when all of us will have the same answer no matter what we chose, okay? So no matter what term you choose, you will get the same answer once we do the simplification part. And so a sub n, I'm trying to squeeze it here, sorry, would be negative 7 plus 2n. Right? I just combined like terms. Remember, we did this on Friday. Arithmetic sequences are the annoying one that you plug in and then you always have to simplify it, okay? With geometric, which we'll go back to tomorrow, you didn't have to simplify. We plugged in, you were done, okay? Everybody okay right there? That's the explicit rule for this, okay? Now, we're going to use that information from Part B to write a linear function. Remember I told you they're the same thing? I'm going to prove it to you right here. So if I'm going to write something as a linear function, I'm going to use slope-intercept form. So I need m and I need b. Well, what's m? 2. M and d are the same thing. Get that in your brain. And b is your y-intercept. You could use the graph or you could use your table, right? B is what your y value when x is 0, so that's negative 7. And I think we all know slope-intercept form looks like this, and you can absolutely write it with all the letters being the same as that. I'm going to write it just a little differently just to show you how you might see it, but it doesn't make a difference. So they're saying write it in this form. They're calling x n. That's why I'm using n instead of x. But could you write x? Could you write y? Yes, you could write whatever you want. But that would be slope-intercept form. Remember, with function notation, it's f of x, g of z. It can be anything, but remember, these two should always match. I'm only writing it in this form to make you guys comfortable seeing it like that and just saying, oh yeah, that's just function notation. Anybody notice anything? This is another big connection. When you simplify the explicit formula, it's in slope-intercept form. Look, negative 7 plus 2n, 2n minus 7. So the simplified version of your explicit form, once you do the distributive property, that's slope-intercept form. That's your a sub 0 plus your dn. A sub 0 plus dn. Okay, let's look at another problem. Here's another arithmetic sequence where they give us the the first term is 17, the 8th term is negative 39, and they want us to state the domain and the range. Okay, domain is our x values, range is our y values. Let's come back to that. We clearly have to complete the table. And they're telling me that this is an arithmetic sequence. So what I know about an arithmetic sequence is as I go left to right, I'm adding the same number every time. But I don't know what these numbers in between are, so how do I figure out what D is so I can be adding it? Well, I want you to start making this, I kind of gave you a hint already. I have 2 points. That's all they gave me. I have 117 and I have 8 negative 39, right? These are your x values, these are your y's. It's a table of values. Call it lots of different things, but that's what it is. How can I figure out what I'm adding left to right when I have 2 points? Yes, I like that you said rate of change instead of just slope. But yes, slope or rate of change. If you have 2 points, you can use your rate of change formula, which is just slope, second y minus first y over second x minus first x. That'll give you your slope. But remember, we already learned that slope and D are the same thing. So we're going to just plug right into slope formula. Call it M, call it D, call it George, doesn't matter. Just plug it in correctly. So second y minus the first y, always y is on top, x is on the bottom. And then you can trust me, I did it in my calculator, I got negative 8. So D or M, whatever you want to call it, is negative 8. So I'm just going to go through the chart. 17 minus 8, minus 8, minus 8, minus 8. You can steal my numbers. I would have done this on my calculator or in my head or whatever. But once I found that number, I knew I was just going left to right, subtracting 8. Okay? Oh, sorry. Sorry. Okay, so what do they want to know? The domain and the range. So remember I said in the very beginning, that last sentence, sequences and their corresponding functions have different domains. In a line, if they said here's some points on a line, you would say the domain, if they said this was a linear function, the domain is all real numbers, the range is all real numbers. We could graph these points, and then we just connect it, okay, with a continuous line, because linear functions are continuous. This is not a linear function. They have a lot of similarities. That's why we can call the m and the d the same. The only difference is, if I graphed these points, I would just leave it like this, okay? That's called discrete. Notice I didn't connect those points. I just graphed those, or they did it for us, graphed the points. They're not connected because the numbers in between are not part of the domain or the range, okay? The domain is 1, 2, 3, 4, 5, 6, 7, and 8. We wouldn't use interval notation. If I used interval notation, and don't write this because you'll confuse yourself if you go back, if I wrote something like that, that would mean 1 to 8 plus everything in between, not just 2, 3, 4, 5, 6, 7, but 1.1 and 1.2 and 1.3, all the little numbers in between. It is not that. It's discrete. It's just these single little x's and just these single little y's. And there are 2 of these in the homework, I think. I'll show you a shortcut so you don't have to write all that out. You can just write D, and I'll show you. We'll do it together. Okay, but we would not be using interval notation on these problems. No interval notation. Okay? Now, using the information we just found in example 2, let's write a linear function whose domain and range would be all real numbers if it were a line. So we're just kind of taking this information and using it to make an equation out of it that would be in line. So remember, to write a linear function, we need m and b. That's what we need. What's m? -8. M and d are the same thing. And b is the y value when x is what? 0. Do we have it? No. But we can find it, right? We can find it. We can just go backwards. If we're subtracting 8 as we go left, right, we would add 8 going right to left. So that would be 17 plus 5, which is 22. 25, right? What did I do? I did on purpose. 17 plus 8 is 25. Okay? So our answer is, and you can write it with y equals mx and all that stuff. I'm just, again, showing you another way you could see it. Recognize that. That's called function notation. F of n, g of x, j of z, whatever. Okay? Function notation. Bottom line is, I should recognize that as a line. It's n to the first power, meaning it's linear. Oh, the number in front of that single variable is my slope. There's my y-intercept. That makes a line.
Are we always going to have to look for the one with the 0?
Yes. You definitely need this number right here. Okay? So we had 1. I need to go back. So that's how I got that number. Okay? Yep. Because just remember, it's your y-intercept, Evan. And y-intercept is when x is 0. Okay? All right. Next page. Another one. This table looks pretty complicated. It's really just going over all the different types of notation representing this graph, okay? So we have a sequence, 32, 27, and so on, and we're going to answer some questions about it. So first of all, remember, term number we can think of as your x's, right? That's this axis right here, your x-axis. So they have filled in 132. We're going to go ahead and fill in the rest of them. I don't particularly like this question because you have to make some assumptions because some of the points are in between. So I wouldn't give you a problem like this on a test. So just go ahead and steal my answers. That is what those points are. Oh, mine is blank. Oh, up here. Oh, thank you. I didn't notice that. I'm going to write myself. This is my copy that I use for each year to year, the one I record with. So I want to remind myself. Thank you. Thank you, guys. I was looking at the graph. I didn't even look there. Okay. So, yeah, just look right there. It says it right there. Okay. So there's my x values and my y values. And think about it. If I asked you to write these in subscript notation, if this is a sub 1, this would be a sub 2, and so on. So that's subscript notation. And then you could put any number in for n. And then function notation, f of 1, so this would be f of 2. So I'm just showing you, this is just lots of different ways of saying the same stuff. Knowing the language. Think of all the different words you have to describe certain things in the English language, like nice is pleasant, whatever other words you can think of. So these are just different ways of naming those. Okay, so first thing we're going to do is write this information in subscript notation. Guys, that's just code for the explicit formula, using the subscript. Here I am writing it again. You decide if you want to write it again. And then we're going to write it in function notation, which is just slope-intercept form. Okay? So let's start by writing this guy in subscript notation. So a sub n, remember, we always leave the n empty. Then you choose which one of these you want to use. Remember, it doesn't matter. It doesn't matter, okay? I'm going to use this one because I'm going to stop being boring. I'm going to pick something different because it doesn't matter. And I should do that more. I should pick different numbers so that you guys can see that it doesn't matter. Okay, wait a second. I need the d value. We haven't talked about that yet. What is the d value? What am I changing by as I go through this? -5. That's -5. And I'm going to put what for my k value? 3. Now, technically, we should simplify this, but guess what? We're about to write it in function notation, which will be this simplified. You'll see. But I'm not going to simplify that to get that. I'm going to start from scratch. Let's pretend all they asked me for was function notation. That means I need m and b. Okay? So f of n, and we're leaving n blank. What is the slope? -5. Remember, they're the same thing. Make that really important connection. They are the same thing. So -5 n, and then what is my y-intercept? So Evan, I don't have it in my chart, right? I just wrote obnoxiously over the 1. I only have 1. I need to go backwards to 0. So if I'm subtracting 5 going this way, I would add 5. So that would be 37. Okay? But I'm not going to take the time to do it, but guys, make this connection with me real quick. If I did simplify this by distributing and combining like terms, this is what I would get. No matter what term I used, like remember I chose 22 this time, the third term, it wouldn't have mattered. When you simplified, you would have had this. That's what's really nice about these formulas. Understand the relationships. It makes this so much easier. Stay with me. This is my favorite question because this is really going to test if you know what this formula is saying, okay? So stay with me, guys. You're doing great. So read the directions. Given the explicit formula for the sequence. They gave us the explicit formula, okay? How many times have we written it? It's right here. Write the first 10 terms of the sequence. So I need to write 10 terms, and I need to pull everything I need out of this. So, guys, I'm being a little obnoxious with what I'm doing here, but it does help to understand this question. I'm going to actually make 10 things. 4, 5, 6. This is not required. It helps me do the problem and teach the problem. So we know we just want the first 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, they gave us that a sub k is 9. Is that my first term? What term is that? Yes. See? The fourth term is 9. That's what they gave us. So 1, 2, 3, a sub 4 is 9. What else can we pull out of there? So we pulled out that the fourth term was 9, and the d is what? -3. So I can very easily now just subtract 3, subtract 3, subtract 3, subtract 3, subtract 3, subtract 3, right? And what am I going to do in the other direction? Add 3. The numbers are going to get bigger as we go in this direction. So there's my first term all the way to my 10th term. Good. I've heard a lot of people say the right answers. All right, find the 200th term. So we already made 10 lines, so we only need to make another 190, right? Yeah, but let's not do that. Okay, remember, the whole point of an explicit formula is to jump ahead in line most of the time. That's why we use it. So we're just going to plug 200 into this formula. We want the 200th term. So wherever I see an N, I'm going to put 200. Now be careful. Be careful. Look, everybody look. Every single one of you pay attention to what I'm going to say. There is no part of this equation right here that is 9 minus 3. It says 9 minus 3, but it doesn't mean 9 minus 3. This is 9 plus negative 3 times the difference of 204. Remember your order of operations. Like I normally write it like this on purpose. I separate a plus and a negative or minus whatever with a plus sign, right? I always put that there for you guys. It wasn't there. That does not mean we change what we do. It's still parentheses first, then multiply by negative 3, did it in my calculator, plus positive 9. So you would get negative 579. The 200th term is negative 579. So be careful. Order of operations. We don't work left to right necessarily in math. We do our order of operations. But it's so tempting to make a 6 right there. It's not. Okay? Order of operations. Times negative 3. Yep. And I just did it all on my calculator. All right. Write the slope-intercept form of that information. I need M. I need B. What's M? Negative 3, right? And then we need A sub 0. $21. Something else you could have done here, guys. So there's my slope, which is D, and then I went backwards, added 3, I got 21. You could have simplified this guy. If you simplify the explicit formula, you would get slope-intercept form. So if I had just distributed and all that stuff here, I would have gotten this. Make that connection. We have one question left. Are we finding this pretty easy? I think it's so cool, the connection between them. Plus, it's like reteaching us stuff. All right, word problem. Let me read to you. Elizabeth waters her vegetable garden using water she collects in a 55-gallon rain barrel. So out in her garden, she's got this big barrel. It's been collecting rain, okay? On May 3rd, the barrel is full. It's full. On May 8th, the barrel contains 47 gallons of water. So let's first interpret what this information means. What this means is our first day, well, don't write anything that I'm about to say, is May 3rd. We're starting with May 3rd. But in a word problem, many, many times our first number is going to be called the 0th term. It's the initial amount. Before time has gone by, May 3rd is when we are starting with 55 gallons. Okay, then the water each day is going to go down, okay? So A sub 0 is usually before time starts. Like you'll see word problems where like you're going to bounce a ball. And the ball starts in your hand at 5 feet in the air. That's your 0th term, 5 feet. Then after one bounce, what is it? After a second bounce, okay? So word problems, remember, a lot of times we use A sub 0 as the initial amount, not A sub 1, okay? Now let's see what they want us to find. Write the first 6 terms. So I'm going to do exactly what I did on that last one to help me organize my information. Optional, not something I would grade, okay? So on the first day, or A sub 0 we're calling it, we have 55 gallons, okay? So this is A sub 1, 2, 3, 4, and on the A sub 5, okay? remember, there was another piece of information there. May 8th is 47 gallons. Well, how do I figure out what May 8th is? Well, if this is May 3rd, this is May 4th, 5th, 6th, 7th, May 8th, there is 47. So A sub 5 is actually May 8th, which is 47 gallons, okay? So that's kind of how I came up with that information. Now, I need to figure out all the ones in between. Arithmetic sequences are just like, sorry, go ahead. Sorry, got it? Sure? Yeah, 0, 1, 2, 3, 4, 5. I know, you want to say 6. Okay, or 4 or whatever. So when we have 2 points, think about it, guys. We have 0, 55, and we have 5, 47. We can find the slope, which is also the D, by using our slope formula. So M or D would be 47 minus 55 over 5 minus 0. You can trust me, I did it in my calculator, and I got exactly negative 1.6. Okay? So second y minus the first y over second x minus the first x. Put it in my calculator, and I got negative 1.6. So now I know my slope or my D. So I'm just going to pick up my calculator and go 55 minus 1.6. That gets me 53.4. And I'm just on my calculator right now subtracting 1.6. You can just steal my answers. 51.8 minus 1.6 minus 1.6. Okay? So remember, if you keep the two in your brains together, M and D are the same thing. Arithmetic sequence and linear equation, same thing. You can use your formulas back and forth. All right, write an explicit rule. Okay, explicit rule. Okay, that's my A sub n equals. Pick which one you want to use. It doesn't matter. I'm going to stop being boring. I'm going to use this one. You use whichever one you want because it doesn't matter. Since I use the fifth term, my K is 5. So I'm going to go ahead and simplify that so that we all get the same answer. 47. Why do I have to pick a hard number? Negative 6. So no matter what number you picked, I used the fifth term, which is 47. When you simplified, you should have gotten this. Okay? There's my explicit rule. That's also slope-intercept form. If the next question said write it in slope-intercept form, I would just write f of n equals negative 1.6n. This is my slope. That's my y-intercept. That's a sub 0. Isn't it right there? When x is 0, y is 55. Whenever you simplify the explicit formula, you get slope-intercept form. Okay, last question. I like this question too because this is a really kind of an AP level question right here. Explain when the rain barrel will be empty. When will the rain barrel be empty? So remember, the height of the rain barrel is these numbers, 55 all the way down. Those are like your y values, right? These are your y values, and these, what day is your x value. So I have a formula I can use. This is a formula that represents this sequence. So when will the height be 0? Empty, 0. No. Y is 0. Remember, a sub n, f of x, this is always your y value. That's the height. And then you just use your calculator and solve that. Subtract 55. Divide by negative 1.6. This is what you get. Okay? Now, how many days is that? It's going to be 34 or 35, and only one of them is going to get you the points. On what day does it fully empty? The 35th day. Because 34 days, there's still a little bit more time left for it to empty, right? It won't be until the 35th day that we're empty. It's almost empty on day 34, but there's still a little bit of time left, okay? Certain questions you don't. Someone, I'm recording, so I don't want to say too much, but someone was talking about an SAT question on a practice test they were working on, and it was something like a recipe, and the recipe called for 2 cups of flour, and you have 3 cups of flour. Can you make a double of the recipe? No, you would have to round down there. Even though you have 3 cups, if your recipe requires 2, you could only make 1 batch of it. So in that case, you would round down. Do you see what I'm saying? So it's just, you have to think about what makes sense. If this represents time, this is 34 days plus a little bit into the 35th day. So when will it be empty? On the 35th day, okay? Good? I know, we make you think in this class, lovey loves. Page 20. Short assignment. I'm going to do the first 2 with you. If you want to do more, they're great questions. I just didn't overwhelm you with too much. So, of course, you can practice. If you want to do more, the key will be on Canvas. Okay, and you're going to see the problems pretty much follow the way the notes went. Number 1, use the graph to complete the table, find D, and write an explicit rule. Okay, so again, this is just pulling points right off of the, do we have the assignment written down here? Yeah, okay. Just pulling the points right off the graph. So we don't have the 0th term, but they gave us the other ones, so here they are real quick for you. Okay, what is the D, also known as M if we needed it? That would be -2, right? So to go backwards, we would add 2. So there's the table. Table done, found the D, D is -2. Now write an explicit rule. Explicit rule is your A sub n formula. Pick whichever one you want. That's a plus. 6 plus -2. I use the first term. My K is 1. Simplify it, please. No matter which one you chose, you should have 8 minus 2n, or you could write -2n plus 8. They mean the same thing, okay? So let me say it for the 1000th time. No matter what number you choose here, make sure it matches here, and we would all have different looking answers here depending on what we chose, but when we simplify, we should all have the same answer if you did the simplifying right, okay? So if you want another one to do, you can do 2, but I did not assign it. I'm going to 3. Good. They gave us 2 of them, already plugged in. We need to finish it, state the domain and range, and write a linear function. Okay, fine. They gave us 2 points. We don't know what D is, but we know D is the same as M. We know we can find M by using our AROC or slope formula, and that's what I'm going to do. Yes, yep. So I have, let's see, the third, what are my 2 points here? I'm just organizing information given. These are the 2 points given, right there in the chart. And I'm just going to use my slope formula, which is the same as D. And I did it in my calculator and I got 4. So that means I am adding 4 as I go left to right. Well, 17 minus negative 7 is the same as plus. Right? So you could write it like that, but when you do it in your calculator or your head, you would end up adding. What? Question? No, you guys talking about, okay. So it says to state the domain and range. Remember I said I'd give you a shortcut? You don't have to write it all out. Here's your domain, y'all. Here's your range. Okay? Those are your x values, just like they're listed. 3, 4, 5, 6, 7, 8, 9, and ranges of those numbers. So you don't have to write them all out if you don't want to. Now write a linear function. All right, I need m and I need b. I got m. M is 4. But I don't know what b is. I can count backwards, so I could subtract 4, subtract 4, subtract 4, up to you. Or I could plug into the explicit formula and then simplify it. So I'm just going to do that really quickly. I'm going to do the explicit formula, pick any term I want. And when I simplify this, I'm now in slope-intercept form. So that's one way of doing it, or I could go backwards to get n is 0 in the chart. Either way, it doesn't matter. When you simplify the explicit formula, you're now in slope-intercept form. Or count backwards to get your 0 term. Choices are good anyway. You guys have about 5-6 minutes, so remember, keep track of what you don't finish so you know you have to go back and finish it.